Okay, so now that we've covered exponents and fractions and adding and subtracting and multiplying and dividing, we're ready to put it all together for order of operations. Very famous acronym when we're doing order of operations is this acronym called PEMDAS, or Please Excuse My Dear Aunt Sally. And we're going to find that there's actually more to the story than that. So we'll great acronym, but we're going to have to kind of doctor it up. So over here is an expression, 48 divided by 3 times negative 2. I'm going to pause for a moment and let you guys kind of work that out on your own, following what you believe PEMDAS is. So let me give you about 20-30 seconds just to try that expression out on your own. Okay, yeah, I'm still here with you, just waiting for you to possibly finish the problem. I know there's some big numbers there to kind of deal with, but as long as the math is right, I usually get two different answers. Some of my class gets negative 8, and the rest of the class gets negative 32. And unfortunately, that should not happen when we're following the order of operations. The order of operations exists so that we follow the same routine for any given expression. And so something's wrong here because we're getting two completely different answers. So let's go back and revisit what this says and how to apply it to this relatively simple expression. So the P usually stands for parentheses, right? That's what we usually say it represents. And we erroneously say that we're supposed to start with parentheses first. So for example, over here I see this set of parentheses, and so most people want to do this multiplication first. However, right, that's not what that P stands for, right? What it actually means is what we're supposed to do is start within grouping symbols first. So you basically start with what's inside them. And when you look at this, there is a set of parentheses, but the only thing that's inside of them is the number negative 2. There's actually nothing, there's no operations occurring. The parentheses are here just to distinguish the 3 from the negative 2 and to let us know that we're multiplying. Imagine if I took away those parentheses, look how drastically that problem changes. And now it looks like I have 48 divided by 3 minus 2. So the only reason those parentheses exist is to tell us that we're multiplying, and that we're multiplying by the number negative 2. The PEMDAS, the parentheses, means we're actually starting within the grouping symbols first, whatever's inside. And of course this opens up a pretty big Pandora's box because there's all kinds of grouping symbols. There's parentheses, there's curly brackets, there's brackets, there's absolute value, there's square roots, and on and on and on. There's actually a whole ton of grouping symbols. And so I think someone along the line just oversimplified this and said, hey everybody, let's just start with parentheses first, and they lost the overall meaning that we're supposed to work with what's inside grouping symbols first. So even though there's a negative 2 in a parentheses here, right, we've established the fact that there's nothing going on inside, so that doesn't really mean I start there. We just keep going forward through PEMDAS. So the next thing says E for exponent. And we just covered exponents. Fortunately for us, there's no exponents going on in this expression, so we don't need to worry about it. The M stands for multiplication, and the D stands for division. And usually, I'll have a student or two tell me, oh, I gotcha, because this says multiplication before division. But that also is not true. When we were covering multiplication and division way back in 1.7, we found that to check our divisions, we did a multiplication. Or we can do a multiplication to check our divisions. As a matter of fact, these two are so intertwined that they almost have the same rules. A negative times a negative is a positive. A negative divided by a negative is a positive. A positive times a negative is a negative. A positive divided by a negative is a negative. So these two actually shouldn't supersede one or the other. So when I have these two together, what takes over is left to right. So multiplication, even though the PEMDAS implies, oh, multiplication should be done first, that is a fallacy, probably an oversimplification of PEMDAS. Multiplication and division actually have the same order of precedence, so when we have them together, what takes over is left to right. A stands for addition, and S stands for subtraction, and we know that these basically have the same thing, right? Subtraction is essentially the addition of an opposite, and heck, addition is basically the subtraction of an opposite. So these two are very similar to each other. So again, when we have these together, we should be traveling left to right. So you can already see there's some nuances that are kind of lost when we just think PEMDAS. Parentheses is one first nuance. We don't start with parentheses first. We actually start with what's inside grouping symbols first. Exponents are followed, multiplication and division left to right, addition and subtraction left to right. And I guess that just kind of screws up the whole please excuse my dear Aunt Sally thing. It doesn't sound as slick. And if anybody can come up with something that adds all the inside grouping and left to right, I'm all ears. The other thing that also doesn't seem to happen when we just literally translate this is when we go through this without understanding, we kind of just think, oh, I'm going to go through this and be done. But it turns out that we're constantly cycling through PEMDAS. So it's something that happens within a problem, within a problem, kind of embedded in a problem. So it's not as linear as the name suggests. So there's basically four things we need to bring to the table to understand PEMDAS completely. That we begin with grouping symbols and what's going on inside. Multiplication to division is performed left to right. Addition and subtraction is performed left to right. And then we just keep going through our PEMDAS as we move along. So with that new understanding, let's go back and take a look at this. So let's see what answer is right. So 48 divided by 3 times -2. So again, PEMDAS would say start with what's inside the parentheses. Well, there's nothing going on inside. So we're done with that step. Next one is deal with exponents. Well, there aren't any. The next thing is to do multiplication and divisions left to right. Well, there's a division there and a multiplication there. So what takes over is left to right. So 48 divided by 3 is going to give us a 16. And then when we multiply by -2, we end up with the correct answer of -32. So -8 is incorrect application of PEMDAS, especially because you're probably reading too much in what the P stands for. It doesn't mean to start with parentheses first. You start with what's going on inside first. So now that we have that new understanding, let's do some more problems. I'll gradually make them tougher as we go. But number one, not only do we have a set of parentheses, but we've got two. But there's nothing going on inside of them. We're just talking about the number -4 times the number -2. So since there's nothing going on inside, we just keep going forward. Exponents, there aren't any. Multiplication and division, well, there's a division and there's a multiplication. So what takes over? Left to right. 32 divided by -4 would give us a -8. And then when we multiply that to -2, the correct answer for that expression would be 16. So again, using our nuances of our PEMDAS. For number 2, there aren't any parentheses, so nothing to start inside. There aren't any exponents, so that's nice. Multiplication and division, well, there's a division right there. So basically we have to figure out, well, what is 20 divided by 5 first? So 4 plus 20 divided by 5 is 4, and then we're still subtracting the 2. Addition and subtraction, we travel left to right. So 4 plus 4 is 8, minus 2. 8 minus 2 gives us a final answer of 6. So again, I'm working through the order of operations with all its little funny nuances. And then the last one for this particular video, same expression almost, but we now have parentheses. So again, it's not that we start with the parentheses first, we start with what's inside. And so traveling from left to right, inside these sets of parentheses, there's an addition. So 4 plus 20 gives us 24. Divided, I haven't done any division yet, so I'll leave it there. 5 take away 2, well, that's 3. And following the order of operations, right, I am working with parentheses, but it's because there's something going on inside. In this set, there's an addition, and in this set, there's a subtraction. And now we're almost done. 24 divided by 3, right? Well, there's no exponents, excuse me. There's no multiplication. There is a division. And when I finish that off, I've exhausted my PEMDAS. So there's your relearning or rehashing, re-explanation of what PEMDAS is. Please continue to use it. It actually is a great acronym, but just be aware of all its little nuances. And as we get tougher, you'll kind of see this next thing where we're going to constantly be working through PEMDAS over and over and over again. But those will come in some much tougher examples. See you guys in the next video.